Hi, so welcome back. In today's video, we're going to be talking about present value and future value of ordinary simple annuity. And I'm going to solve the questions in this video using the BA2 Plus Texas Instrument, the financial calculator. Okay, so let's get started on that. So here we have a question that states that Catherine saved $550 at the end of every month in a savings account, earning 2.5% compounded monthly for 10 years. What would be the total value of Catherine's investment at the end of 10 years? So the first thing in a time value of money question is to draw out our timeline. So we'll draw out our timeline, and the next thing we could do is draw out our interest rate, right? Write down our interest rate, which is 2.5% compounded monthly as given. Now, the next thing is we got months from 0 months all the way up to 120 months, and our payment is $550 occurring at the end of each month. Now you might be asking, how do we get the 120 months, right? How do we get there? So what happens is that we have 10 years. So Catherine is investing the money for 10 years, and she's investing it at the end of each month. So it's 10 years, and in 1 year there are 12 months, right? So 10 times 12 is going to give us 120 months. So your n number of terms is going to equal 120. Our I per y is going to equal 2.5%. Our present value, we don't have any present value, is going to equal 0. Our payment is going to be $550, and our future value is also going to be 0, right? So now the question is, what are we exactly solving for here? Are we solving for present value or future value? The question asks us, what would be the total value of Catherine's investment at the end of 10 years? So technically, we're looking for the value, not in year 0, not in month 0, my bad, but at the end of 120 months, the total value of her investment. Right, so we're actually solving for future value of the annuity. So we can use the time value of money variables, and we can simply plug it into our calculator. So the time value of money variables are laid out here again. Your n is 10 years times 12 months, which is equal to 120 terms. Your interest rate is 2.5%. Your compounding frequency, so compounding per year, is 12 months because the interest is compounded monthly at 2.5%. We don't have PV, so we already stated that we don't have any PV. Our payment is $550 at the end of each month, and our payment is also happening at the end of every month, so it's 12 times a year. Now, I'm entering it as a negative. The reason why is because we want to compute a positive future value, and in order for us to do that, we have to enter the PMT as a negative $550. Think of it as if the $550 are going out of your pocket and into a savings account. So although you're saving it, but it's still going out of your pocket. So think of it as like that, right? So now let's go ahead and plug it into our calculator.
So since we have already identified the variables, let's quickly punch it into the calculator. We know that our n is 120, so we're just going to write 120. I'm just going to press n. Now our interest rate is 2.5%, so we're just going to write 2.5 and press I per y. We do not have any present values, so we're just going to press 0 and click PV. We have a payment of $550. Remember, we're going to put it in as a negative, so it's 550, and you use this button, you just change it as a negative and press that in as for PMT. Lastly, we don't have a future value, so we're just going to click 0 and enter future value for now as 0. Now, the other thing we need to remember is that our C per y and P per y are 12. So in order to change that, we press the second function and we press I per y. And as right now, it's showing P per y of 1 and C per y of 1. So in order to change that, all we do is just press 12 in P per y and press enter. And it's automatically going to change for P per y and C per y for both of them at 12. And now all we have to do is just press clear off and compute and future value. So the future value of the investment is going to equal $74,894.57.
So that means that Catherine's investment at the end of 10 years is going to equal $74,894.57. Okay, great. Now let's move on to the next question. Okay, so this question states that Sean settled a loan by making payments of $1,500 at the end of each quarter for 12 years. What was the amount of Sean's loan? What was the amount Sean borrowed if the interest rate was 3.5% compounded quarterly, right? So what we need to do before we start anything is to draw out a timeline. So when we draw out a timeline, we got quarter 0, and we go all the way up to quarter 48. And we know that our interest rate is 3.25% compounded quarterly as given in the question. Next thing is we look at our payments, which is $1,500, and it happens at the end of each quarter, all the way up until quarter 48. Now again, how do we get to quarter 48? That's by taking your 12 years, so that's your 12 years, and you multiply by the frequency, which is quarterly, the installment that's happening. It's 1,500, 1,500, 1,500 is happening quarterly, so it's 4, and whatever we get is 48. Now, what we need to know is, when do we calculate the value of Sean's money, right? So it's saying what was the amount Sean borrowed, right? If the interest rate was 3.25% quarterly. So it's asking in the beginning, right? Not what was the amount that he has to pay back, like what was the total value of the loan. It's asking what he borrowed. So it's asking for present value of annuity, right? So now that we've laid out our variables, we can use our table and just organize it so that it's easier to punch it into the calculator. So we know that our N is equal to 12 years and our 4 quarters in a year. So that's why your N is equal to 48. We've already calculated that. Your interest rate is 3.25%. So it's Sean's interest rate is 3.25%, and it's compounded quarterly. Compounding per year is 4 times a year because there are 4 quarters in a year. Now, the payment, again, we're going to enter the payment in as 1,500. Actually, this time they are going out of his pocket and he's losing that money. So it works out perfectly fine in this, but we're going to enter that in as a negative, and your future value is just going to be 0. So now let's quickly just plug this into our calculator and see what we get.
So as we have already identified the variables, we're going to punch it into our calculator now. So we have 48 as N. So N is your 48. Your interest rate is 3.25% compounded quarterly. So I'm just going to just 3.25 for now. We don't have a present value. I'm just going to enter in that as a 0 for now so that we don't make any mistakes. So that's 0. Our PMT is 1,500, so it's 1,500. And we're going to enter in that as a negative. So that's that. And we don't have any future values. We're going to enter that in as 0 as well. Now, remember, we need to change our C per Y and P per Y. So we could just quickly do that. Again, second, I per Y. And we'll get the same 12 from last questions. We're just going to press 4. We're going to press enter. And our C per Y and P per Y are changed to 4. So we're just going to click clear off. And now we're going to click compute and PV. And there we go. We have a present value of $59,423.14.
So now we have that. Now we know that Sean's total value of the loan was $59,423.14. So that means that Sean borrowed $59,423.14. So he has to repay that back. He's making that payments by making $1,500 of installment at the end of each quarter. So now that's it for this video. If you liked it, please give it a thumbs up. If you have any questions, please write in the comments, and I would appreciate if you just subscribe to my channel for more content like this. Thank you.